Okay, and welcome to the final video on circles, where we will cover the properties of circles, and we'll do that quickly, and then we'll get on to looking at tangents and normals, which you will see throughout the A-level course when you're looking at curves as well. So let's get into some basic properties that you might have seen from GCSE as well. Right, so the angle in a semicircle is always a right angle, something you definitely see at GCSE. The perpendicular from the centre of a chord bisects the chord. So if you have a perpendicular line, if you draw a line from the centre of the circle to the chord, it will cut the chord in two. Okay, bisect, so this will be the perpendicular bisector. And this one is quite important here. The tangent to a circle is perpendicular to the radius at the point of contact. Okay, so a tangent to the circle is always perpendicular to the radius. This one is not as common, but could be used as well. To find the centre of a circle given any 3 points, you could use the following technique. Find the equation of the perpendicular bisectors of two different chords, and then find the coordinates of the intersection of these perpendicular bisectors. Okay, so you can only do this if you've got 3 different points. Okay, so you find 2 different perpendicular bisectors, you find the midpoint here and here, and you find the perpendicular bisectors, and then you do some Hess equations with them. Okay, right, so let's come up to the final page in the booklet to do with circles, where we look at tangents and normals. Okay, so a circle 2, 3. Before we get into that, the coordinates of the centre and the point on the circle can be used to find gradients of tangents and normals. So I'm just going to do a quick sketch. A tangent to a circle is a line that touches on the outside of the circle. Okay, a normal to that line will more or less be the equation of the radius. Okay, because it's perpendicular to the tangent. So let's look at question 1, part A. A circle has centre 2, 3 and radius 5. Write down the equation of a circle. Well, using the skills from the first video in circles, we should be able to do this fairly straightforward. Okay, so the equation of a circle, x minus a squared, x minus 2 squared, y minus b squared, y minus 3 squared equals 5 squared. Okay, so we've got that circle there, and that's sorted. We've got the equation of it. Verify that the point P lies on the circle. The point P is given as 5, 7. Now, for you to verify that a point lies on the circle, what we have to do is take this equation and think, okay, for a point to be on this circle, if I put the coordinates of the point in here, if I put the x coordinate point there and the y coordinate point there, if I substitute them in, does it make 5 squared? Does it make 25? So let's try that. The point is 5, 7. So I'm going to substitute 5 for x and 7 for y. Okay, so 5 minus 2 is 3. 3 squared is 9. 7 minus 3 is 4. 4 squared is 16. So you get 25. So the 0.57, when you put that into the equation of the circle, gives you a value of 25, which means that the length from the centre to the point P is the same as the radius. Okay, so therefore P lies on the circle. Okay, so the next part of the question, find the gradient of the line CP. So gradient of CP. To do that, you do y2 minus y1 over x2 minus x1. So 7 minus 3 over 5 minus 2. 4 over 3. That's the gradient of the line, CP, okay, which is given there. And that's correct because it's positive. y2 minus y1, x2 minus x1. Not an issue there. Right, part D. Find the gradient of a line which is perpendicular to CP. So if I have a gradient of a line perpendicular to CP, so I'm going to call that M2, that will probably be minus 3 over 4. Yeah, we did this in straight lines. You flip the fraction, you do the reciprocal of it, and you change the sign. Hence, find the equation of the tangent and the normal to the circle at the point 5,7. So let's do the tangent first. Okay, so remember, this is the tangent here, this line, which just touches the circle at the point P. Now, tangent is a straight line. What three things do we need for the equation of tangent? If you remember, we need an x value, a y value, and a gradient. The x value will be any point that the tangent has. So it's going to be x equals 5, y equals 7. And the gradient will be the following. Well, we know the gradient of CP. And if we remember our geometry from the previous page, this line, this gradient CP, or this line CP, is perpendicular to the tangent. Therefore, we can use M2, which is minus 3 over 4. Therefore, the equation of the tangent is this. Okay? Now, for the normal, the equation of normal, as I said before, is the equation of the line that's perpendicular to the tangent. So in this case, it's the equation of the radius. We know a lot about that. We know an x value, which we could use as a centre. We know the y value, which is the y value centre. And we know the gradient of CP, which is 4 over 3. So I could use y minus y1 there. Okay, so I've done the equation of the tangent and normal. So those are skills that we're using, and you've got to be able to bring things together in such a way. Okay, so you'll be using straight lines knowledge for sure, and you've got to be able to apply that to circles equations. So here are the practice questions outlined and the stretch and challenge. I would highly recommend that you have a go at finding the equations of tangents and normals to a circle. As I said, you'll be finding the equation of tangents and normals to curves later on in the course. So it's very important that you remember tangents and normals of straight lines. You need the three things, and how do you find those three things? If it's from the information, easy peasy. If you have to find gradients and do the negative reciprocal, then that's a bit more work. Okay, that's the end of the video. Good luck.